Hi, I'm Leslie, and I'm here today to talk about magnetic resonance imaging. This is an MRI of my very own head. It was not anything all that serious. They were just checking on an inner ear issue. The MRI techs gave me the images on a CD to then take to my doctor a few days later, and I am not the person to do that with because I, of course, immediately figured out what program I needed to download to to see the images and spent the next 48 hours poring through them. So let's talk about how MRIs work. Yeah, just some little mini lessons or reminders if you've heard this before. Individual protons or hydrogen nuclei behave like tiny magnets. They have a north pole and a south pole or a magnetic dipole moment. The human body contains a lot of water. Overall, approximately 60% of the body and approximately 73% of the brain is H2O. Those two hydrogen atoms in each water molecule present the possibility of harnessing the magnetic field energy. Under normal conditions, the individual little proton magnets are not aligned. They are pointed in all directions with no combined magnetic effect. However, if the body is placed in a strong magnetic field, then the individual magnetic dipole moments begin to line up and they will exhibit a net magnetization. So let's talk first about that dipole moment. So a proton with its magnetic spin produces a magnetic field and acts as a small bar magnet with a north and south pole. In the presence of an external magnetic field, labeled here as B naught, this magnetic dipole moment will rotate around the magnetic field with a motion known as precession. Now, to understand precession, I think it's easiest to picture a top spinning because it's not just spinning about its own central axis. The type of it is also drawing a circle in the air, and that circle is the direction of precession. So when you make a solenoid coil magnet, an electric current, labeled here as I, flows through a wire conductor and produces a magnetic field. If the wire is wound as a solenoid coil, shown here how it's wrapped up like that, then it produces a uniform magnetic field, once again labeled B naught, and it's established through the center like that, which is where the patient would go. Now, for the sake of time, we won't get too much into the weeds here about all these different coil sets. But so the RF coil goes inside the gradient coil set, all of which are positioned inside the middle of the magnet, which is where the patient goes in, usually on some sort of motorized bed. So once again, without straying too far into how a Fourier series is used to translate the information from the machine into a picture, here is an image produced by an MRI machine. Basically, unhealthy tissue, like the tumor shown here, does not show up the same way with the same amount of contrast because it doesn't contain the same amount of water. A different amount of water means that it has a different precession rate. This one's not me, by the way. This came out of a book that I have cited at the end. So without going into the math and instead just taking a qualitative view of this, the basics are that these precession rates are what is known as the radio frequency. Based on the radio frequency pulse, an energy absorption process will take place, and this phenomenon is known as resonance. Subtle differences in the way water is incorporated within tissue affects the characteristics of the RF signal received, and manipulation of the RF and gradient pulse sequences determines the image contrast. So, and if you're seeing the word resonance there and thinking, oh, that's where the name comes from, just a fun fact, MRI machines were originally called nuclear magnetic imaging because really that's what they're doing, but people were too afraid to get into a machine with the word nuclear in it, and so they had to remove it so people would feel comfortable, and that's how we got magnetic resonance imaging as the common name that we use today. Most of the information that I have presented here, I learned from a book called True Tales of Medical Physics. That it's actually a compilation of stories from doctors and medical physicists that were all put together and edited by Jacob Van Dyke. And then I also took a few of the images that I used from the website listed below. Thank you very much. I hope you all enjoyed it and hopefully learned something.